Chaitanya sir, please mute yourself. Yes, please all of you mute yourself. If you want to say something, then only unmute.
Yes, madam. We have some doubt about in some of the problems in the assignment.
Yes,
can you
yes.
please help us?
Today, as after this session, means last 15 minutes, we'll discuss on that. Okay.
Okay. Okay. Yeah. Thank you.
Yes, so this is what we have done last week, where the transform functions and answer in terms of S. So basically, Laplace transform of any t function, time variable function, is giving you the answer as the function of S. So in the new domain, okay. So this is the basic definition which we are using for all the functions which are satisfying the condition of the Laplace transform, that it should be a exponential order function and it is a piecewise continuous function. Then we can find out it's a Laplace transformation by the integral 0 to infinity. One of the function is exponential term e raised to minus st, other is your function of t. Okay, and we have seen few functions like constant function k, then e raised to at function whose transformed answer is 1 upon s minus a. Similarly, transformation for sine of at function is giving you the answer as a upon s square plus a square. This is f of s function. Similarly, for the cosine function, the answer will come out as s upon s square plus a square. And like that. Okay, so some two hyperbolic functions we have seen and one algebraic function we have seen, that is t raised to n part. Okay, so this is your transformed answer, which is in terms of gamma n plus 1 upon s raised to n plus 1. Now with the help of this, let us define some properties and work out with that. So properties of the Laplace transforms. Properties for the Laplace transformation. The first property, I'll be taking it as the shifting property. So it is actually a frequently used property and many of the differential equations contain the output system in this form. So we will take this as one of the important property and let us see what happens to the transformed answer for this one. Okay, so you can just take down this thing. It is a shifting property. Generally, it is called as a first shifting property. So every time the consideration is this: if Laplace transform of f of t is equal to function of s, then Laplace transform of e raised to at multiplied by f of t is giving you the shifting of s to s minus a. So this shifting is taking place with the help of this multiplication. So s is shifted to s minus a when you are multiplying f of t with e raised to at function. So that change you have to consider. So every time if you know the f of t function transform, then only you have to see that if it is multiplied with exponential function, in the answer of that f of t, you have to shift s to s minus a. So identify what is a and put it there so that we will be getting that particular answer. And therefore, if Laplace transform e raised to minus at, if it is there with f of t multiplied, then certainly the answer will be f of s plus a. Means actually we are writing bar. So f bar of s minus a, f bar of s plus a, like that. So this is a shifting property. For example, Suppose, because I know some standard function transforms. So if I want to calculate the answer for find Laplace transform of, say, e raised to 2t into sine of 3t, suppose. This is a required function transform. Find the transform of e raised to 2t into sine of 3t. So what is f of t here? What is f of t?
Sin 3t.
Sine 3t. So can you tell me quickly what is its a transform? What is sine 3t transform? Because we have calculated for sine 80. I hope the formula list is there with you. And already we have done in the last lecture.
S upon S square plus 9.
Now you are telling me cosine. I'm asking about sine. Sine function transform is this one.
3 upon s square plus 9.
Yes. So this is 3 upon s square plus 9. A answer is 3. So we are getting the transformed value as 3 upon s square plus 9. This is your fs function. It's actually f bar s. Okay. This is f bar s. And therefore, when you multiply this sine 3t with e raised to 2t, then what change you have to make in the fs function? You have to write f of s minus a. A is what here? What is a?
2.
2. So this should be f bar of s minus 2. Means what? In the answer you have to, in the answer of fs, wherever there is s, put s minus 2. That means 3 upon s minus 2 square plus 9. That's it. You don't have to calculate the answer. Otherwise, if you don't remember this property, then you go directly by the definition of the transform, that is integral, 0 to infinity and all that. So that integral has to be evaluated, and which should give you the answer as 3 upon s minus 2 square plus 9. So that is the transformed value. Got it? Or any difficulty? Yes, anything? Any difficulty or any doubt regarding this?
And do we have to solve it like s minus 2 square is a minus b square and expand it and solve it?
No, at present, just keep it as it is, because we are just doing the calculations for the transform. In the latter part, we will be doing inverse transform. And then together we are solving the differential equation. That time you solve. Okay,
Okay.
at present, just keep it as it is. So find the another example, you can take it. Find the Laplace transform of, say, t square e raised to minus 3t. T square into e raised to minus 3t. So here, what is the f of t function?
T square.
T square. So can you tell me what is its answer of the transform? So Laplace transform of t square answer we want. So use t raised to n formula.
Two upon S cube.
Yes. So answer for Laplace transform of t raised to n का formula है n factorial. Is it correct? N factorial upon s raised to n plus 1. Because this is a integer. 2 is the integer. Okay, so we can use the factorial notation. So this is gamma n plus 1 means n factorial upon s raised to n plus 1. So here this is 2 factorial is 2 upon s raised to 2 plus 1, that is 3. So this is your f bar s function. And therefore Laplace transform of t square e raised to minus 3t. What change you will make it in fs function? What do you write?
S plus 3.
S plus 3. Very good. So this is f bar of s plus 3. That means in the answer of Laplace of t square, You have to replace s with s plus 3. That means 2 upon s plus 3 bracket cube. That's it.
आता ही मी तुम्हाला शेअर केले की
Okay. Any difficulty following no this one?
Yes, ma'am.
Yes, ma'am.
So we'll move ahead with another property. That is next property, second property, you can add it here, the derivative property. Okay. Laplace transform of the derivative of the function, because this also is required in the differential equation. Laplace transform of the derivative property means derivative of the function f of t. Okay. So what we can, this is a generalized expression where first derivative answer is used to find out the second derivative, then second derivative answer is for the third derivative, and like that the nth derivative answer. Okay. So again same consideration, if Laplace transform of f of t is equal to f bar s, then Laplace transform of the derivative. So derivative is written as dash, f dash t means d by dt of f of t. D by dt of f of t can be written as s into f bar s minus f of 0. I'm not putting bar. Minus f of 0. Please write correctly and carefully. Laplace transform the derivative, first derivative of the function is s into f of s minus f of 0. Now f of s, as you can identify that it is a transform of this t function. So f of t function. But this f of 0 is nothing but the value of the function. Value of the function at t is equal to 0. So this is limit of f of t at t tending to 0. That can be understood. Okay. And f bar s is of course a transform of f of t. This is the first derivative answer. Similarly, Laplace transform of the second derivative of the function. That means Laplace of d square f upon dt square can be written as s square f bar s minus s into f of 0 minus f dash 0. Three terms are there. S into f of 0 minus f dash of 0. S square f bar s minus s f of 0 minus f dash of 0. Once again same, f bar s is a transform of f of t and f of 0 is the value of the function at t equal to 0. And f dash 0 is also the value of f dash t at t equal to 0. Okay, this should be understood. And this will be given to you in the example so that you can find out the answer. And therefore, likewise, you can continue for third, fourth, fifth, etc. derivative like nth derivative. So if I take nth derivative formula, Laplace transform nth derivative of t, that means d raised to nf upon dt raised to n is equal to, now can you tell me what will be the first term it will start from? Generalized form.
S raised to n into f
S
of
raised to
f
n
dash of
into f bar s minus what do you
S
write?
raised to n minus 1. N minus 1.
Correct. F of 0 minus s raised to n minus 2, f dash 0, and etc. All the negative terms. Ending term will be what? F raised to
F of 0.
see, the second derivative result is ending at f dash 0. So nth derivative result will end at
n minus 1.
F raised to n minus 1. huh.
S pressed to n
Yes,
minus 1.
f raised to n minus 1, 0. Okay, so nothing difficult in remembering the formula because it should start from s raised to n. Then you can reduce the powers of s, attach f of 0, f dash 0, and etc. So up till when? Up till f raised to n minus 1, 0. You have to consider. Okay, so that will be the expansion for Laplace transform of nth derivative of t. This you have to remember as a standard formula. And according to your first derivative, second derivative, you will have the calculation. Okay, for example, find Laplace transform of d square f upon dt square plus 2 df by dt plus f of t plus f of t when when f of 0 is equal to 0, f dash 0 is equal to 1. Okay, so suppose this is a given condition, then we are finding out the Laplace transform only derivative terms. Okay, so as per the linearity rule, separate all the terms and take separate Laplace transform of each term. So this is 2 times df by dt plus Laplace transform of f of t. And now here we have to use the second derivative result. This is f double dash plus 2 into Laplace of f dash. And last term is just f of t. Okay. And therefore this will come out as, now this will start from s square f bar s minus s into f of 0 minus f dash 0 is the first bracket. Okay. Then second bracket is the first derivative. So plus 2 into, it will start from s into f bar s minus f of 0, second bracket term. Okay. And the third bracket, what is the Laplace transform of f of t? You will write. What is the transform of f of t?
f bar
Fs.
of s.
Yes, so just write f bar of s. And therefore, you will collect the f bar s terms. So this is one f bar s term, this is one f bar s term, this is one f bar s term. And put the answer for f of 0, f dash 0 in the given expression. Okay, given condition, using given condition. So this is s square plus 2s plus 1. I'll take it on in one bracket. F bar s is common. Then f of 0 is 0. This is given to you. So this is 0, f dash is 0 is 1. Okay, this is given. So here also this is coming 0. And you will be getting the answer as minus 1. That's it. That will be the transform of the differential term. Have you got it? So actual use of this derivative property we'll be doing in the differential equation solution. This is only the differential part which I have shown you, how the property can be applied and get the result of this f bar s. Okay, that's a differential property with the help of Laplace transform. We are finding out the answers, and differential equations are of course at the most up to second derivative you will get it, not more than that. Okay. And one more property we will take, that is a multiplication by t property, because this also is frequently used in the differential equation. So property 3 you can have, this is multiplication by t, multiplication by t.
Hello.
So yes,
Hello. Madam, why we have taken here -1 after
that
f
answer
of
for
x bar s?
f dash is 0 is 1, no?
Uh-huh.
This is written.
Okay. Okay.
Yes, so next one is multiplication by t property, where again same consideration. If Laplace of f of t is equal to f bar s, is equal to f bar s. Then first t raised to 1 multiplication, then Laplace transform t into f of t, means t raised to 1 into f of t is nothing but minus 1 d by ds of f bar s. If you compare this result with our z transform, it is of course on the similar line we have done. Okay, derivative z transform ki bhi same property है इस type की. And if you multiply by t square f of t, that will be minus 1 square d square upon ds square of f bar s, second derivative. And like that, if you multiply by t raised to n f of t, certainly right hand side will be minus 1 raised to n, nth derivative of f bar s with respect to s. Okay, so just remember properly this property, and generally we are using this property when t is multiplied with sine or cosine function. If t is multiplied with e raised to at function, then we will use the first shifting property. Okay, no use of this property because this is little bit calculations are more in this case. Whereas in the shifting property, which we have seen first, that is very easy to use when just because of s to s minus a shifting is there. But here in this case, we have to differentiate the term. So for example, if I take, so find the Laplace transform of, say, t into bracket cos of 2t. Suppose this is a calculation required. So in this case, f of t is, what is f of t?
Cos 2t.
Cos 2t. And what is its transform? What is cos 2t transform?
S square upon s square plus a square.
S upon, not s square. Numerator is s only. S upon s square plus a square, that is a square is 4 here, 2 square. So s upon s square plus 4 is our f bar s function. Are you getting? And therefore, when you multiply this cos 2t with t, you have to apply the property here. That is minus 1 raised to 1 d by ds of f bar s. And f bar s just now we identified. So minus d by ds of s upon s square plus 4. And this is simple differentiation calculation. U by v rule, because numerator is a function of s, denominator is also containing s. So minus n I'm keeping outside as it is, using the differentiation u by v rule. I hope all of you have studied this. Differentiation of u by v is v into du by dx minus u into dv by dx upon v square. This is the rule. D by dx of u by v, suppose it is asked, then we will be doing this one, this way calculation. So here this is our u, numerator is s, that is u, this is u, and this is v. Just apply differentiation. So what happens? Denominator s square plus 4, numerator ka differentiation, that is ds upon ds, which is 1, minus s will be as it is numerator, denominator ka differentiation with respect to s, that is 2s, and the whole thing divided by denominator's square. Correct? Following?
Yes,
Yes.
sir.
And that gives you, just simplify. So this is 2s square with negative sign plus s square. So this minus s square is remaining. So I'll be getting the answer as s square minus 4 numerator upon s square plus 4 the whole square. This is correct? Following, no, this one, how it is coming?
Yes, ma'am.
So with this multiplication property, we have to just differentiate the terms on the right hand side, fs function, and then simplify, so that we will be getting this particular result. Okay. And this last one also, I'll just to tell you, which is nothing but convolution, which we have seen in the Z transform also. Convolution between the two functions. Okay, so the same property of convolution. Convolution between two functions or three functions. That means, once again, if Laplace transform one function, I'll take it as f1t, whose answer is f1 bar s, and Laplace transform of say f2t is f2 bar s. Then if there is a convolution between these two functions, f1t star convolution, we take it as a star operation. f2t is equal to, convolution between two will give you the answer as f1 bar s into f2 bar s. Okay, that multiplication. So convolution star operation will convert into the multiplication on the right hand side between the s function, s domains. Okay, and that way we will be getting the answer for this convolution property. For example, suppose again, if I want to calculate, find the Laplace transform of t square star with e raised to 3t. These two are the functions, t square and e raised to 3t. So you should know what is the transform of t square and transform of e raised to 3t. So here f1t is equal to t square. Tell me what is its transform? What is t square transform?
2 upon x cube.
2 upon s cube.
Q. Correct. So previous example only we have done this way. Similarly, f2t is your e raised to 3t. What is its transform?
1 upon x minus 3.
Yes, 1 upon s minus 3. So this is your f1 bar s, this is your f2 bar s, and therefore when you do the convolution between this, t square star e raised to 3t is nothing but 2 upon s cube into 1 upon s minus 3. That's it. So that will be the calculation with the s domain. Okay, so we'll be of course doing all these simplification in the differential equation. So this is how the properties can be used while solving the Laplace transform problems. Now on the similar line, how we have defined the inverse Z transform, similarly here we will define the reverse way, inverse Laplace transform. So whatever the transformed answer for the standard functions we have done, just make it opposite, means reverse back, and so that we will be getting the original function f of t. Okay, so next heading as such you can put it as inverse Laplace transform, where, so since if Laplace of f of t is equal to f bar s, and therefore when we take inverse transform of f bar s, it should give you the original function, that is a function of t. I hope you can understand this thing. Okay, and therefore all the standard functions, which are giving, like for example, if I want to calculate inverse transform of k upon s, what is the answer for this right hand side? If you have written the formula, then tell me. Have you written?
Okay.
K. The answer is K. K का answer है K upon S. So original function is K. Similarly, inverse transform of, if I or I will just write down this because you are You might have forgotten this thing. Laplace transform of e raised to at is 1 upon s minus a. Therefore, inverse transform of 1 upon s minus a is e raised to at. That you can understand. Similarly, Laplace transform of, say, sine of at is a upon s square plus a square. Therefore, inverse transform of, now generally inverses are only for the s function. So if there is some constant or anything, can be shifted on the other side and written it as sine of at upon a. आ रहा है समझ में? Inverse transform of 1 upon a square plus a square. Following or not? This one, a I have shifted on the other side because that's a constant. Inverse and
No,
Laplace.
ma'am, explain it.
See,
No, ma'am, explain. Will you please explain?
yes, this is a function of t, which is giving you the answer as fs this way. But in that case, that a is your constant. So you need not have to keep it in the inverse calculation. That constant can be brought here. If you keep it, it doesn't matter. That will be just multiplied outside. But otherwise, we will take inverses are only for the fs function. Constant वगैरह अगर उसमें है, तो वो आप दूसरे side पे shift करो. So when numerator is a, on the right hand side हो जाएगा, तो it will come in the denominator. So that is why it is written as 1 upon a sine of at. Got it?
मैम एक एग्जांपल लेके आप ये सॉल्व कर सकते हैं.
Yes, we'll be doing. I'm just writing all the functions first of all. Similarly, cos of at if it is there, then whose transformed answer is s upon s square plus a square. Now in this case, numerator is containing s. It's a function of s. So you need not have to shift it on the other side because inverse जो होगा वो s function का ही होगा. So this is together and that is giving you the answer as cos of at. Similarly, for the hyperbolic functions, which we have done, sine hyperbolic at is equal to a upon s square minus a square. So the inverse transform again for 1 upon s square minus a square will come out as sine hyperbolic at upon a. And similarly, cos hyperbolic function, if it is there, whose transformed answer is s upon s square minus a square. Therefore, inverse of s upon s square minus a square will come out as cos hyperbolic at. And lastly, this algebraic function we have done, t raised to n wala, which is giving you gamma n plus 1 upon s raised to n plus 1. Therefore, inverse transform of, now once again gamma n plus 1 is always a constant. So only s wala function जो है वो यहाँ पे रखो. So s raised to n plus 1 का answer will come out as t raised to n upon gamma of n plus 1. Or, now generally n plus 1 नहीं होगा ना, any power of s will be there. So we can write down the answer for s raised to n as t raised to n minus 1 upon gamma n. आ रहा है समझ में? Or any difficulty? Only formula I have written. How reverse way you can get the answer as a function of t. Okay. Similarly, left side of this last seventh formula is also in the form of factorial notation. So n factorial upon s raised to n plus 1. So you may write Laplace inverse of 1 upon s raised to n as t raised to n minus 1 upon gamma n, or this can be written as n minus 1 factorial. Okay, or it can be, if it is a integer, then you can write down the answer as n minus 1 factorial. Okay, for example, now just see. Now formulae are there with you and I hope you are writing it in the notebook. So please refer that and tell me. Okay, For example, if I want to calculate the answer for Laplace inverse of 1 upon s plus 4, can you tell me by looking into your list of formulae, this formula which I have given just now?
E raised to minus 4t.
Yes, this is a e raised to minus 4t transform because this is your answer, no? E raised to 80 का answer है 1 upon s minus a. I have got it as 1 upon s plus a. A is your 4. So that is only the change. If I want to calculate the answer for Laplace inverse of, say, 1 upon s square plus 4. Now can you tell me under which formula it will come? 1 upon s square plus 4. 1 upon s square plus 4 is this one. Third formula. Correct? What is the answer?
Sin 80.
Sin 2t by 2.
Yes. So this is
Sin
sin
2t
2t
by
upon 2. That's it. Similarly, inverse transform, suppose if I want 1 upon s raised to 4, then which category, which function it is? कौन सा formula use करोगे? Which one? Which formula you will use? Find 1
T
upon
raised
s
to
raised
n.
to t raised to n, seventh one. This result is showing 1 upon s raised to n formula. That is t raised to n. Now, and that n is a integer. This 4 is the integer here. So we will be getting the answer as t raised to, answer क्या है इसका? T raised to n minus 1 upon n minus 1 factorial. So t raised to n means 4. 4 minus 1 upon 4 minus 1 factorial. That means t cube upon 3 factorial. Got it? Suppose if this inverse is asked, 1 upon s raised to 3 by 2. Now this is not an integer, so we have to use the gamma function. That means t raised to 3 by 2 minus 1 upon gamma 3 by 2. ये formula लिखा है ना हमने. And therefore this is t raised to how much you are getting? 3 by 2 minus 1 means t raised to
half.
T raised to half upon gamma 3 by 2 can be written as 1 by 2 gamma 1 by 2. Last time we have written the reduction formula for gamma function. So n gamma n when it is n plus 1. Okay. So using the property of gamma function, n plus 1 is equal to n gamma n, and using gamma half is equal to root pi. This is a standard form. And therefore our answer becomes t raised to half means root t upon 1 by 2 into root pi. Correct? So 2 root t upon root pi. That is the value of 1 upon s raised to 3 by 2. Followed? Similarly, if I have another... Yes. Which one you want?
No, ma'am, the last.
Madam, please show last step, last answer.
Yes. Third one, no?
Yes, madam. Thank you.
Got it, no? Good.
Yes.
So just try this one. Find inverse of 1 upon s square minus 9. Or, okay, just take it this one, s square minus 9. Similar to which formula it is?
Cos 80.
No, just see carefully. Correct. So it is a formula sine hyperbolic function. This one we have done. ये वाला.
Fifth one.
Fifth one. And A is here 3 again. So you are getting the answer as sine hyperbolic 3t upon 3. That's it. Similarly, if I have this one, s plus 5 upon s square minus 9. Suppose this is the example. Then what I will do, I will first of all, because it is not a standard function, but I can express it as a standard function because numerator is containing 2 terms. So split them and write it as inverse of first function as s upon s square minus 9 plus, now that 5 is constant, which you can keep it outside and just write 1 upon s square minus 9. Got it? Following? And now tell me, what is the first term and what is the second term transformed answer? What is the inverse transform of this one?
Cos hyperbolic.
Cos hyperbolic
by
3.
3.
Yes, so this is cos hyperbolic 3t. It's a function of s numerator upon this one. Plus 5 as it is. And second term is a
Sine
sine
hyperbolic.
hyperbolic. Yes. So this is sine hyperbolic 3t upon 3. Correct? Upon 3 will come, no? So that is a function of t. Remember, when you take inverse transform, right hand side should be completely a function of t. And when you take only transform, right hand side is a function of s. Okay, so these are the terms which should be remembered according to the formulae. So whenever now you know Laplace transform, how to take and how to take the inverse transform. So now our main purpose of learning this topic is to solve the differential equations. Okay, so in the differential equations, now you have to apply both the methods, and there generally we use the partial fraction method for this inverse Laplace transform, like how we have done it in the Z transform. Okay, so just we will take one example here and then we'll go to the differential equation. Okay, so write down partial fraction method.
Madam, I have one question. Madam, these 3, from where 3 is coming?
Which one?
Like cos h 3t and sin h 3t. So from where we are taken 3?
Because denominator is containing s square minus 9, no? That means 3 square.
Okay.
Just
okay.
compare this
So that
result
is-
with standard results, no? Here I have given a formula. Standard result is A, which is A upon s square minus a square. So A is your 3.
Yeah.
That we have taken.
Got it, ma'am.
Right. Partial fraction method for the inverse transform. Inverse Laplace transform. So just I'll tell you how this can be done. Okay, and already the partial fraction kya hai that we have seen in the Z transforms. So only thing is here your fraction contains S function. Okay, so if first one you can write down, if the fraction, first fraction containing the denominator numerator upon s minus a, s minus b factors in the denominator can be written as a upon s minus a plus b upon s minus b. Split the factors into 2 parts, and that's why it's a partial fraction, and get the answer for a and b, and therefore numerator of the left hand side is equal to numerator of the right hand side. So that will come out like this. Find the values of a and b by putting the answers for S, two values of S by putting two values for S. Okay, so you will be getting the answer for A and B, and then inverse can be applied in that case. Okay, so that is the procedure. Or in the second form, you can have, if the fraction contains the repeated factors in the denominator, like S minus A factor is repeated twice and another factor is S minus B, then we may write this as A upon S minus A plus B upon S minus A ka square and plus C upon S minus B, because denominator is now of degree 3. So there are three unknowns A, B, C, and they are to be determined like this one. Okay, if the fraction contains some numerator upon denominator term as a quadratic expression. Yes, anything? Anybody
Hello?
wants to? Yes.
Ma'am, yes, ma'am. Please wait for 2 minutes.
Yes.
I'm writing down. Yes, that's all.
Okay.
हेलो
हम्म
मैम, जो सेकंड नंबर का दिखा है ना आपने, उसमें ए बी और सी कैसे इवेल्युएट करेंगे? सेम वे से है?
Same way, numerator of the left hand side, numerator of the right hand side, and put three values for S.
Please, if you elaborate that.
Yes, we are solving the example. This is just a procedure I am giving.
Okay, ma'am.
And third procedure can be for the quadratic factor. So this is a quadratic factor and this is a linear factor. So we will be getting again the degree 3 in the denominator, where you can write the quadratic factor as as plus b as a numerator upon this quadratic factor as plus a square plus as plus b, and one linear factor is s minus c, for which you can write down another constant, say capital C upon s minus c. Upon s minus c. And same procedure again, numerators from both sides are equated by putting three values of s, so that you will evaluate a, b and c, capital A, B and C. That's it. Okay, that is the procedure for the partial fraction form. So once
in the third equation, hello, C
yes.
upon S minus C only, no?
C upon
Right
S minus C.
side.
Yes, this is a linear factor, no? So only S minus C. Yes, for example, suppose if I want to calculate inverse transform of 1 upon, say, S square plus 5S plus 6. Suppose this is my function of S. Then what I can do, I'll try to split the denominator as the linear factors. Can anybody tell me the factorization of this?
Plus 1.
Yes, so this is S plus 3 and S plus 3. That's it. Correct. So two linear factors you are getting S plus 2 and S plus 3. Now together we cannot solve as the inverse transform, but if we separate them part wise, then we can solve. So what you can write is, let 1 upon S plus 2 into S plus 3 is equal to A upon S plus 2 plus B upon S plus 3. Correct? Are you getting? This is a fraction form. First one, what we have written is non-repeated linear factors. So two factors are there. Degree of the denominator is 2, and therefore two unknowns we are finding A and B, capital A and B. Now, numerator of the left hand side is 1, numerator of the right hand side is a into s plus 3 plus b into s plus 2. I hope this you can understand. Left hand side 1 is equal to a into s plus 3,
Yes,
right
ma'am.
hand side numerator this one. Now you can put two values of s which are suggested from the given factors. So put s is equal to say -2 and put s is equal to say -3. So a and b का answer मिलेगा. So if you put s is equal to -2, you will get the answer for a. Can you tell me what is a?
1.
1. And if you put s is equal to -3, then you will get the answer for b.
-1.
-1. That's
Minus
it.
1.
And therefore, your fraction 1 upon s plus 2 into s plus 3 is nothing but 1 upon s plus 2 minus 1 upon s plus 3. And now when you take its inverse transform, both sides, you have to take the inverse transform of the right hand side also. Is 1 upon s plus 2 minus inverse transform of 1 upon s plus 3. 1 upon s plus 3. And this comes under which formula? 1 upon s plus a inverse transform. क्या आंसर होगा इसका? 1 upon s plus a. Which formula?
E raised to
A
minus
upon
8.
S plus 2.
Yes. So e raised to minus 2t minus e raised to minus 3t. That's it. Following?
Yes, madam.
Yeah. So generally, whenever the denominator contains this quadratic term or cubic term, you try to find out or split it into the linear factors. The answer is very, very easy because linear factorization, when you do and when you operate inverse transform on that, answer is always exponential function. Okay, in terms of that. But otherwise, if sometimes it is not possible, then of course you have to use the standard formula and get the result. As another example, I can just take it this way. Find inverse transform of 5 upon s square plus 1 into s minus 3 into s minus 3. So once again, denominator is containing, what is the degree of the denominator? What is the degree of the denominator?
It's a 3, no, madam?
3.
3.
This is quadratic and this is linear. Okay, quadratic means degree 2, linear means degree 1. 3 is the degree, together degree is 3, means there should be 3 unknowns. And how you will write down 3 unknowns? For the quadratic factor, the numerator term is written as the second procedure of partial fraction. Ye wala. Sorry, not this one, third one. Third one. That is, denominator contains the quadratic factor and one linear factor. So here also we will write down like that. So this is 5 is of course constant. If you want, you can just keep it as it is and write it 1 here. 5 afterwards we will take it. हाँ एक मिनट. Yes, so how do you write this one? Fraction form? So numerator is as plus b square plus 1, and another factor is c upon s minus 3. Correct?
Madam, why we have taken here 1?
No, no, 1 I am
divided by-
taking it first. This 5 we will take it out afterwards. We can write down like this. 5 into L inverse of this thing. So that 5 anyway, in the latter part we can multiply. Okay. So just to get the constant in the simpler form. And therefore numerator of the left hand side is 1. Right hand side numerator will be as plus b into s minus 3 plus c into s square plus 1. Are you getting? Numerator of the right hand side.
Yes, ma'am.
And then find out a, b, c. So first value, so you can immediately put that is s is equal to 3 and get the answer for c. So what will be c value? Tell me.
1 by 10.
1 by 10. Yes. And now other two values you can put anything, any least values of s, so that calculations will be little bit easy. So I can put s is equal to, say, suppose 0. Put s is equal to 0. Then what happens? Left hand side 1 is equal to a into 0 is of course 0. 0 minus 3 means minus 3. So minus 3 into b only will come this bracket. And in the second term, if you put s is equal to 0, that will give you just the answer for c. Okay. And now here, if you put the value for c as 1 upon 10, you can get the answer for b from here. Similarly, if I put s is equal to next value, if I put like 1, okay, just random values you can put. And I'm telling you that least values. Least means 0, 1, minus 1, 2, minus 2, so that calculations should not be so difficult. Otherwise, it will give you some error. So left hand side 1 is equal to s equal to 1 means you will be getting a plus b into 1 minus 3 means minus 2 plus c into bracket 1 plus 1 is 2. Have you got the answer for b? Anybody got the answer?
Minus 3 by 10.
Minus 3 by 10.
Minus
3 by
1 by
10.
1 by 30.
Just I have to check then. It's not correct. 3 by 10. So if you put c equal to 1 by 10, 1 minus 1 by 10 will be 9 by 10. 9 by 10 equal to minus 3b. So 9 by 30 is the correct answer. Getting? Are Anna same? Minus 3 by 10.
Yes, ma'am.
That's correct. And next,
Yes,
now
ma'am.
you put a plus b, sorry, b answer you know, c answer you know. So you can get the value for a here. Yes, anyone calculated a? Chaitanya sir, please mute yourself.
Minus 1 by 10.
Yes, so minus 1 upon 10. Good. So all the three values you got it, put it there. Therefore, 1 upon s square plus 1 into s minus 3, giving you right hand side as plus b. A means minus 1 by 10 into s plus b, that is minus 3 by 10 upon s square plus 1 plus C. C is 1 upon 10 divided by S minus 3. Okay, and therefore L inverse of 5 upon S square plus 1 into S minus 3 is equal to 5. I can keep it outside and I can take L inverse of, now this is, you can take curly bracket, S upon means minus 1 upon 10 into S. So this is S minus 3 or minus S minus 3 upon 10 divided by S square plus 1, and second term plus L inverse of 1 upon 10 upon S minus 3. So both the terms are of course multiplied by 5, that is remembered. Okay, so this is 5 into bracket, here I can complete this curly bracket. So 5 into bracket, curly bracket. Now inverse transform, in that also you can keep this 1 by 10 outside. Negative sign, if you want, you can keep it outside and just take the inverse transform of S plus 3 upon S square plus 1. First term. Second term also 1 upon 10, you can keep it outside and take inverse transform of 1 upon S minus 3. आ रहा है समझ में? Okay. And which gives now 5 is outside. So minus 1 upon 10. Now here, once again, you split the two terms because there is no standard formula containing this one. So S upon S square plus 1 is one term. 3 upon S square plus 1 is another term. So it is inverse transform of S upon S square plus 1 and plus 3 into L inverse of 1 upon S square plus 1. This is the first bracket. I'll put square bracket here. And second term is 1 upon 10. ये तो आएगा आपको inverse transform 1 upon S minus 3. Standard formula is there. Now everything is in the standard result form. So minus 1 upon 10. Tell me what is S upon S square plus 1 inverse transform? What is the inverse transform? इसका क्या आएगा?
Cos t.
Yes.
Ma'am.
Yes. So this is cos t function that you can identify easily. Cos t. Okay. Plus 3 into bracket. What is this?
3 sin t.
Why? 3 into sin t. That's correct. Very good. And last term. What is the transform of this? 1 upon S minus 3.
E raised to 3t.
Yes. So e raised to 3t. That's it. Any doubt? Anybody? So we'll be getting.
No, ma'am.
This is, if I multiply by 5, this is minus 1 by 2 cos t plus 3 into 5, that is 15 sin t plus 1 by 2 e raised to 3t. That's it. That is the final answer in terms of t. Okay, shall we move ahead? So inverse, how to get it with the partial fraction form, that is the important thing while solving the differential equation. Now let us see one or two differential equations.
Here I have one query.
Yes.
Madam, that first 1 by 10 common is also common from second term, na? 3 sin t.
Yes, 3 sin t, yes, correct. So this is actually, and that is minus sign, no? So it will come. Yes, here it is plus, okay, but this will be minus 3 upon 10 sin t. That's correct. Good. Calculations also see carefully. So minus 15 upon 10. This is 3/2 sine t, that will come. So let us see 1 or 2 examples in which differential equations are solved with the help of Laplace transform. Okay. So applications of Laplace transform to the differential equations. Differential equations. Now, whenever the differential equation is given, both sides transform you have to take, and then further you can take the inverse transform. So I'll just give you the procedure in wordings. Consider Laplace transform of both sides of the equation, and which gives f bar s is equal to some function of s, which gives this f bar s means some function of s. Some function of s, and then take inverse Laplace transform. Inverse Laplace transform on both sides, which gives the original function f of t, function of t as a solution. Okay, so two things you have to do. First, you take Laplace transform, find fs function, then take inverse transform and find the ft function. So conditions will be given to you. You have to just apply and get the result into that form. Okay, so let's take it as an example. We take it. Solve d square y by dt square minus 2 dy by dt minus 8y is equal to 0 with, this is a condition given, y0 is equal to 3 and y dash is 0 is equal to 6. Y dash is 0 is equal to 6. Now here the Laplace transform derivative property is first of all to be used in all the differential equations. Okay, so consider Laplace transform of the given equation on both sides of the equation. So we will take Laplace of d square y by dt square minus 2 into Laplace of dy by dt minus 8, I'll take it outside, Laplace of y means y of t. This is understood. Equal to right hand side, anyway now here it is a 0. This is right hand side is 0. Laplace transform of d square y by dt square minus 2 Laplace transform of dy by dt minus 8 into Laplace transform of y of t is equal to right hand side 0 hai, isliye Laplace transform 0 will come, that is 0. And now using the derivative property, of the Laplace transform, तो क्या है वो derivative property? Laplace transform of what we want, double derivative. If double dash t का answer we have written, that is s square f bar s minus s into f of 0 minus f dash 0. This property already I have given you. Okay, and Laplace of single derivative का answer है s into f bar s minus f of 0. And of course Laplace transform of f of t is nothing but f bar s. So here instead of f, this is given as y. Okay, that you can understand. Instead of f, this is given as y. So f double dash t, you can replace it by y double dash. This is y dash and this is y. Are समझ में? So your answer will be y bar s, you can write. F bar s की जगह y bar s लिखो. That's it. So here, therefore, this becomes, I'll call this as number 1. Therefore, 1 becomes first term s square y bar s minus s into y of 0 minus y dash 0. Am I right? First term minus 2 into dy by dt का Laplace transform.
Please, can you explain it again?
Here the property we have written. This property is clear or not?
Yes, ma'am.
Y double dash, we are writing it as s square. In place of f of s, you write y bar s. This is f of 0 means y of 0. F dash is 0 means y dash is 0. Like that. Okay. So I want second derivative Laplace transform, first derivative Laplace transform, and y of t transform. And that is nothing but, so first term I am writing it like this. This is your first term. Minus 2 into second term. That is s into y bar s minus y of 0. आ रहा है समझ में? Yes? Following or not?
Yes, ma'am.
So last term is minus 8 into y bar s. At right hand side 0 ही है, तो there is no difficulty. You will be getting the answer 0 itself. Otherwise वो भी कुछ s का function होता. So in this case, now the terms y0 and y dash 0 are given. What is y0 given? So y0 is given as 3, y dash 0 is given as 6. So put it there. So this is 3, this is 6, this is 3. And we will collect y bar s की जो terms है वो सब collect करो एक bracket में. Therefore, y bar s into, what will be the bracket term? What will be the coefficient of y bar s?
S square minus 2s minus 8.
Correct. S square minus 2s minus 8. And now remaining terms are multiplied with y0, y dash 0. So just calculate them. So minus 3s, then minus 6. And from the second bracket minus minus plus 2 into 3, that is 6, is equal to 0. Correct? So this 6 and 6 is also getting cancelled. And therefore we get y bar s is equal to 3s upon s square minus 2s minus 8. Got it? Yes or no?
Yes, ma'am.
Please repeat that step, second last one.
Ma'am, here
Ma'am, this
first
is
term
y
is
bar
not
yes, no?
multiplied.
Yes. This is a half part of the solution. So this is, I'll call this is number 2. So y bar s, you got it. Now you want the solution means yt. Function of t as a solution you want. So we have to consider, of course, the inverse transform. Okay. So therefore, consider now inverse transform of 2. Consider Laplace inverse of equation 2. So left hand side inverse transform of y bar s. Okay, this is y bar s is equal to inverse transform of 3s upon s square minus 2s minus 8. Okay. So what is your left side? What is your left side?
Y of t.
Yes, so this is y of t equal to right hand side. Can you tell me denominator factorization? Is it possible linear factors?
S minus 4 into S plus 2.
Very good. S minus 4 into S plus 2. And therefore, now linear factor means you can apply now partial fraction method. Two factors are there. Therefore, consider, if you want, take it separately. Otherwise, here also you can do. Consider 3s upon s minus 4 into s plus 2 as a upon s minus 4 one factor, b upon second factor. Partial fraction form, first procedure, non-repeated linear factors. This is a partial fraction form. Now tell me what are the values of a and b by equating both sides in numerator. So 3s is equal to a into s plus 2 plus b into s minus 4. So one time you can put s is equal to minus 2 and put s is equal to 4. And get the answer for b here and a here. Tell me what is a and b?
A is 2, B is 1.
A is 2 and b is 1. Is it correct, all of you?
Yes, sir.
Yeah.
Yes, ma'am.
So put it there. And therefore, your fraction form or from equation, I can call this as 2. Okay, this is actually.
B is, ma'am, please check the B.
B answer is not
minus,
correct.
1 by 2, I think.
You're putting s is equal to minus 2, no? So minus 6
Yes.
right hand side will come. Minus 6b is equal to minus 6 on the left side.
Minus 1 by 2.
No. You're putting here also, na, s is equal to minus 2. Left side.
B is 1, ma'am. It's correct.
Correct. No, this is correct value.
Yes.
You have not substituted, I think, s equal to minus 2 on the left side. Left side में only 3 nahi hai. This is 3 into minus 2. It's correct answer. Good. So you can call this as number 2 or 3, whatever it is. So y of t from 3, therefore y of t is equal to inverse transform of L inverse of a means 2 upon s minus 4 and plus 1 upon s plus 2. Okay, and just separate them because of the linearity property. So 2 upon s minus 4 plus inverse transform of 1 upon s plus 2. Now this is a very simple formula. What is the first term?
2 raised to, 2 e raised to 4t.
Yes, 2 into e raised to 4t. And second term
Plus
is?
e raised to minus 2t.
Yes, e raised to minus 2t. So y of t is equal to, this is your complete solution. Following?
Hello.
Yes.
Madam, please repeat that step. S square y bar of s minus s y of 0 minus y dash of 0. How it comes s square minus 2s minus 8? This one.
See, I have collected only the terms of y bar s. Which are the terms of y bar s? Just collected. So this is your y bar s term. This is your y bar s term. and this is your y bar s term. So that is taken out, and remaining is the coefficient. So s square here from this, from here 2s, and from here 8.
Yes, yes,
Got,
ma'am, yes.
got it, no?
Okay, thank
Yes.
you. Oh, yes, yes.
So just identify, but because of this, solution is based on two terms. What you get y of s, as accordingly you will be getting the inverse transform. So suppose this term itself is wrong, then further if you do correct also, it doesn't have any meaning. So this should be correct value of fs. Then only you will get the inverse transform, and then final answer is the function of t. Okay, so very carefully and correct calculations do it, so that the answer will come into that particular form. Okay. So let me take one more example, and then we will discuss your difficulties from the assignment. Take down this one. Solve the differential equation dy by dt minus y is equal to e raised to 3t for y of 0 is given as 2. Y of 0 is given as. So actually this is more simple than the previous one, because here only the first derivative, it's a first order differential equation. Okay, so let us take Laplace transform on both sides. On both sides. So we'll take Laplace transform of dy by dt minus y. Minus y means y of t, you can understand. And right hand side is not 0 now, it is e raised to 3t. So separating two terms, dy by dt. dy by dt means y dash minus Laplace transform of y of t is equal to Laplace of e raised to 3t. What do you write the first term? Tell me now. Yes, what will be the first term? Y dash का आंसर क्या है? Laplace transform y dash
S y of s minus y of 0.
minus y of 0. Very good. Minus second term is just y bar s. Okay, and right hand side tell me e raised to 3t का transform.
1 upon s minus 3.
Yes, so 1 upon s minus 3. Okay, and as usual, collect the terms of y of s. So there are two terms on the left hand side. I'm taking it out. So the coefficient is s minus 1. And what is y0 given? So y0 is given as 2. So you can put here 2. So minus 2 will come out. Right hand side 1 upon s minus 3. And therefore y bar s is equal to 1 upon s minus 3 plus 2, and both terms multiplied with s minus 1. Is it correct? Any difficulty? And that means you will be getting y of s as 1 upon s minus 1 into s minus 3 pehla term, and second term 2 upon s minus 1. We'll call this expression as 1. So So this is everything is on the right hand side in terms of S we got. Now you take inverse transform. Now consider inverse Laplace transform of 1. So L inverse of y of S is equal to 1 upon, L inverse of 1 upon S minus 1, S minus 3, and L inverse of 2 upon S minus 1. So now here you can apply the partial fraction. Left side is of course y of t equal to. Here you can apply the partial fraction form, that is a upon S minus 1 plus b upon S minus 3. Inverse. नागरिक 10 मिनट 1 मिनिट नागरिक So this is plus L inverse of 2 upon S minus 1, so you can find out by the formula. Anybody got the answer for A and B?
A is minus 1 by 2 and B is 1
Correct.
by 2.
And B is
1 by 2.
1 by 2. Very good. And that gives me, this is minus half into inverse transform 1 upon S minus 1 plus half into inverse transform 1 upon S minus 3 plus 2 into inverse transform 1 upon S minus 1. The very simple standard formula is there which you have to use on the right hand side. So who will tell me the answer for this then? Minus half
Minus 1
into
by 2 e raised to t.
Madam,
E raised
yes,
plus 1 by 2
plus 1 by 2 e raised to
e raised to 3t. 3t
correct.
plus
ma'am,
2 e
when
raised to t.
I think Chaitanya sir wants to ask anything. Yes sir.
y of t जेव्हा काढलं मॅडम ते सॉरी a आणि b त्यावेळेस ती टर्म जी आहे 2 अपॉन s minus 1 ती कन्सिडर नाही केलं का a आणि b च्या वेळेस
नाही ह्याचं ऑलरेडी दिस वी
ही
कॅन
term
फाइंड आउट ना स्टँडर्ड आन्सर ते तसंच ठेवलंय.
मग त्याला डायरेक्ट इक्वेट टू 0 केलं का आपण त्या टर्मला कन्सिडर न करता इक्वेशन मध्ये
कुठल्या टर्मला 0 केलं?
या 2 अपॉन s minus 1 ला त्याच्या a आता ह्याचं कसं होईल a into s minus 3 आणि b into s minus 1 प्लस s
एक
ही
मिनिट
टर्म
एक मिनिट चैतन्य सर एक मिनिट. कशाची चावी म्हणते ह्याची रूमची? हा ती माहितीये मला. हा 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 आणि लॉक करू नका, मी आहे इथे, किल्ली माझी तिथे. हा नाही नाही तिकडची रूम पण 500च लॉक करू नका. हो विसराल म्हणून सांगते. ठीक आहे ठीक आहे. जमवायचं तर काय. हा चैतन्य सर सांगा काय तुम्हाला प्रॉब्लेम आहे.
मॅम ती 2/s-1 टर्मची आहे ती कन्सिडर नाही केली का? ते डायरेक्ट a इंटू s-3 प्लस b इंटू s-1 0 केलं का इक्वेट टू?
हा 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 नाही इक्वेटेड टू 1 दिस थिंग. हे जे आहे ना आपण लिहिलंय हे पहिलं हे फक्त दिस फ्रॅक्शन इज रिटर्न फॉर 1/s-1 आणि s-3 ला लिहिलंय आपण. सेकंड टर्म तशीच ठेवली आहे कारण त्याचा आन्सर डायरेक्ट येत आहे.
नाही पण ते इक्वेट करताना न्यूमरेटरला इक्वेट केलं लेफ्ट हँड साइडला तर
न्यूमरेटर 1 इक्वल टू झालं ना ते.
+2 नी येत आहे ना ते मग +2 तो नाही कन्सिडर केलं का आपण?
नाही तुम्ही ही जी थर्ड टर्म आहे ना ही बाजूला ठेवा ना. ही आपण पार्शियल फ्रॅक्शन मध्ये कन्सिडर करत नाहीये कारण त्याचा आन्सर डायरेक्टच येत आहे आणि तिथे मी 2 बाहेरच ठेवलंय ना ते. आय थिंक ते तुम्हाला विचारायचंय का? मी इथे मला वाटतं हा हा बरोबर आहे ना. मग इथे 2 ठेवलंय ना बाहेर हे 2 तसंच ठेवलंय. हा
ए आणि बी कॅल्क्युलेट करताना ते 2 ला कन्सिडर नाही केलं ना डायरेक्ट 0
नाही
कन्सिडर
नाही ती
केलं.
वेगळी ठेवली आहे टर्म आणि हे फक्त याचं केलंय पहिले. सो यू आर गेटिंग दिस. आता इथे पाहिजे तर तुम्ही क्लब करू शकता फायनल आन्सर मध्ये -12 e⁻t प्लस ½ e⁻3t आणि लास्ट टर्म इज 2 into e⁻t. तर आता ही 2 e⁻t आणि -½ e⁻t यू कॅन क्लब. सो ½ e⁻3t मी पहिल्यांदा लिहिते आणि मग 2 -½ 2 -½ किती येणार? 3/2 e⁻t. दॅट्स इट. ते तुम्ही समजा पार्शियल फ्रॅक्शन मध्ये ती पण टर्म कन्सिडर करून घेतली असली तरी चालतंय. बट अदरवाइज सेपरेटली बाय कॅल्क्युलेटिंग दिस y of t function then write down the answer which is a solution. ओके अजून काही प्रॉब्लेम आहे?
मॅम एक्सक्यूज मी 3/2 कसं आलं हे नाही कळलं मॅम.
कुठे आलं 3/2?
3/2
कोएफिशियंट्स करेक्ट केले ना -½ आणि इथे 2 आहे ना 2 -½ इंटू e⁻t असं आलं ते. त्याचा आन्सर 3/2.
ओके
4 - 1 म्हणजे 3 आणि अपॉन 2. ओके एनी अदर?
मॅम स्टार्टिंगला एकदम सगळ्यात स्टार्टिंगला जितके फॉर्म्युलेस तुम्ही दिलेत ना ते हवे होते मला. ते मला हवे होते लिहून
म्हणजे कॉपी करायचेत का?
हा हा हा
हा नाही मग हे मी ऍक्च्युली रेकॉर्डिंग पण पाठवतेच आहे आणि ह्या नोट्स ऑलरेडी आहेत क्लासरूम वरती तर तुम्ही त्यातनं पण घेतले तरी चालते. त्याच्यात पण स्टँडर्ड फॉर्म्युले लिस्ट आउट केलेले आहेत.
दिस फॉर्म्युले मॅम दिस फॉर्म्युले.
हा तर ते घ्या ना तुम्ही त्याच्यातनं घ्या. आता मी थोडस ते मागच्या असं आता हे दिस इज व्हॉट इट विल बी देअर इन द लाप्लास ट्रान्सफॉर्म फुल पोर्शन. जेवढं मी सांगते त्याच्यातलं असाइनमेंट आणि तुमच्या एक्झाम मध्ये येणार आहे. ओके टिल नाउ व्हॉट एव्हर वी हॅव डन. सो बेस्ड ऑन दिस
मॅम ऍक्च्युली मी ते क्लासरूम ओपन करते ना ते मला असाइनमेंट हे मिळत नाहीये. तुम्ही जे शेअर केल्यात ना ते खरंच मिळत नाहीये. तुमचं जे मेल मधून मी चेक केलं ना
मला वाटतं असाइनमेंट मी व्हॉट्सअप ग्रुप मध्ये पण शेअर केली आहे. व्हॉट्सअप ग्रुपला पण नाहीये का तुम्ही?
आहे मी आहे लिस्ट. अच्छा ठीक
बघा
आहे मी
बरं
तिकडनं चेक करतो.
हा एकदा चेक करून घ्या. नाहीतर मग परत एकदा पाठवते किंवा मग वाणी मॅडम जर असेल तर पुन्हा एकदा शेअर करा त्याच्यावरती.
हो मॅडम. मॅडम असाइनमेंट व्हॉट्सअप ग्रुपवर नाहीये.
नाहीये का व्हॉट्सअपच्या याच्यावरती?
आहे 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 सॉरी मॅडम आहे.
मी पाठवली असं मला
8 फेब्रुवारीला
आहे मॅम व्हॉट्सअप ग्रुप वरती.
आणि सगळ्या नोट्स क्लासरूमवर आहेत
दिसतायत ना. ते काहीतरी प्रॉब्लेम असेल तुमचा इंडिव्हिज्युअल तो फक्त सॉर्ट आउट करा आणि ते क्लासरूम वरती तर आहेतच आणि मी शिवाय व्हॉट्सअप ग्रुपलाही म्हटलं तसं मी पाठवते. त्याला पण अटॅच करून ठेवते तुम्हाला पाहिजे तिथून.
हा मॅम व्हॉट्सअप ग्रुपवर पाठवा नाही तर असं हे सगळं.
मॅडम व्हॉट्सअप ग्रुप वरती आहे.
हा
मॅडम मला पण क्लासरूम वर ओपन नाही करता येते म्हणजे प्रॉब्लेम आहे
मलाही नाही येते मॅम क्लासरूम मी ओपन करण्याचा प्रयत्न केला.
ठीक आहे मी पाठवते व्हॉट्सअप ग्रुपलाही पाठवते आणि असाइनमेंटही
मॅम
पाठवते.
याच्या आधीच्या पण नोट्स पाठवा मग.
हो ना, मग
सगळ्याच.
सगळेच ना, झेड ट्रान्सफॉर्मचे आणि लाप्लास ट्रान्सफॉर्मचे. आणि आता मी परवा दिवशी ह्याच घेणार आहे, फोरियर ट्रान्सफॉर्म, ते पण पाठवते, सगळे नोट्स पाठवते.
हो हो चालेल. चालेल.
आणि रेकॉर्डिंग मात्र मग क्लासरूम मधनं घ्या, कारण ती युट्यूबची लिंक आहे, त्याच्यात मी व्हॉट्सअपला पण शेअर करते ती लिंक, आणि त्याच्यातनं रेकॉर्डिंग पाहिजे तर ते बघा. हा, एनी अदर?
Madam, one request.
Madam?
Is it possible to extend the due date of our assignment submission by 2 days, madam? Because I'm also facing some problem to find out the answers. So we required at least 2 more days. Is it possible, madam? Because tomorrow is the due
केव्हापर्यंत
date
पाहिजे
for our
तुम्हाला?
assignment
हाऊ
number
मच
2.
टाइम यू रिक्वायर? टिल सॅटरडे?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
That will be fine, madam.
ठीक आहे, I'll
Till
extend the
Saturday
date.
at least. Till
Okay then.
Saturday.
Okay, I'll do.
Okay,
Saturday.
madam. Thank you.
Thank you, ma'am. Thank you.
Google Classroom. Thank you, madam. Thank you.
In Google Classroom, I will extend the date. So till Saturday now. After that, don't ask me again the extension, because further your new part will start, and this study will be totally different from that. So again, coming back to the assignment will be difficult for you also. Yes. So now I think Vani madam, problem you wanted
Yes,
to
ma'am.
discuss no, regarding this is Z transform.
Yes, madam. In the question, from question 1, the sub question 5, f of k is 2 raised to k upon k. Find Z transform. In that I am having problem in finding when 1 upon k is added now. 2 raised to k upon k. So it will be first of all for 2 raised to k, na? Z upon Z minus 2, right?
Yes. And divided division of k property is to be used, integral.
Yeah, then integration will be there, right?
So integration of what you are doing?
I am having problem in that only.
So you are doing the integration of what? Z upon?
Z upon Z minus, no, but Z is getting cancelled. Z from numerator is getting cancelled. So it is 1 upon Z minus 2.
And
in that only I am having problem. In that integration I have problem.
Okay, so f of k is just 2 raised to k upon k is given, no?
Yeah.
So when you
or
find
k
out
is equal to or greater than 1.
That is causal sequence only.
Yeah.
So transform of fz answer is z transform of 2 raised to k you are taking, which is z upon z minus 2. Correct?
Yes.
And therefore using this division property, division by k, z transform of 2 raised to k upon k is equal to integral z to infinity of fz, z raised to minus 1 into fz you have written.
Yes.
Right? So this is z to infinity, z raised to minus means 1 upon z, and this is z upon z minus 2 dz. So this z and z is cancelled, and we'll be getting just dz upon z minus 2. I think you got this one, no?
This much I got. I'm not able to do the integration.
Yes. Anybody, any other student have done this problem?
Log of Z minus 2.
And the limits you are putting, no? Log of Z minus 2, that is the answer for this one. Limit says up to Z you are increasing. Okay, up to Z means just keep it as it is.
Okay.
So, yes, so this will be just a log of Z minus 2. That linearity property is there, no? Vani madam, this 1 upon x integration, this is a formula for integral terms using this one. Dx upon x minus a is log of x minus a. This is the integral formula that we are using. So this is a linear term, z minus 2. So we are getting the logarithmic answer.
And then we have to put the limits, right?
But limits means here we are taking it up to z only. So don't put
Okay.
infinity as such. So you can write down directly as integral limits up to z. Not z to infinity, but up to z because of the causal sequence. K is greater than or equal to 0. This is given. Okay.
Okay.
So just get the answer in terms of that log of z minus 2. Any other?
Yes. One more. Last problem. Solve the difference equation. The question आहे f of k minus 9 f of k minus 2 is equal to u of k.
And u
Where
of k is
greater
given.
than or yes, k is greater than or equal to 0 and u of k is equal to 1 by 2 raised to k. Where for k greater than or equal to 0 and it is equal to 0 for k less than 0.
This is
मॅडम
a
या
unit
टाइपचा प्रॉब्लेम आपण झाला नाहीये क्लासमध्ये असं मला तरी वाटतं म्हणजे मी
unit
videos
step
करत
function दिलाय ना मी तुम्हाला property. This is a unit step function.
Yes.
So actually right hand side जे आहे ते unit step function आहे असं. Half raised to k greater than or equal to 0 and k less than 0. The answer is 0. Okay. So फक्त positive part मध्ये it is existing. So left hand side चे तुम्ही z transform घेणार. F of k minus
that we
9
can do.
into left side चे तर घेता आला
That we can do. Yeah.
राईट हँड साइडला z ट्रान्सफॉर्म uk जेव्हा करणार तेव्हा यू हॅव टू कन्सिडर द z ट्रान्सफॉर्म. आता तिथे दोन रिजन्स आहेत फक्त k ग्रेटर दॅन इक्वल टू 0 लाच डिफाइन केलेलं आहे. सो यूज z ट्रान्सफॉर्म ऑफ uk म्हणजे z ट्रान्सफॉर्म uk स्टँडर्ड फंक्शनचं दिलं असेल मी तुम्हाला कदाचित किंवा तेही वापरायचं नसेल तर इथे z ट्रान्सफॉर्मचं डेफिनेशन काय आहे? काय असतं z ट्रान्सफॉर्मचं डेफिनेशन? समेशन ऑफ
f of
k म्हणजे u of k.
f of k. That is u of
to minus k
into z raised to minus 1.
आणि k
minus
from
k.
0 to infinity कारण हे पॉझिटिव्हला फक्त डिफाइन आहे म्हणून. म्हणजेच काय समेशन ऑफ हाफ रेस टू k into z raised to minus k from 0 to infinity. If you put k is equal to 0, you will be getting the answer as 1. Correct? If you put k is equal to 1, this is half z raised to minus 1. Plus, if you put k is equal to 2, half z raised to minus 1 square. And like that. म्हणजे ही series आहे geometric series whose convergence is nothing but a upon 1 minus r. Summation is a upon 1 minus r. हा फॉर्म्युला दिलाय तो वापरायचा तिथे. करता येईल.
Okay. So this will be on right hand side.
This is on the
a
right
upon
hand
1
side.
minus r.
तर जे काय आन्सर येईल ते fz मध्ये येणार.
Whatever the ratio
take the
is.
inverse transform.
Okay.
तरी येत नसेल तर कळवा मला. I'll just show
Yes,
you
yes,
किंवा मी I'll send you in the WhatsApp group.
Yes, ma'am. I'll try. I will try. Yes.
आणि आता लाप्लास ट्रान्सफॉर्मचे जे आज केलेत आपण प्रॉपर्टीज आणि स्टँडर्ड फंक्शन त्याच्यावरची ही दोन एक्झाम्पल्स करा. जस्ट टू नॉट टू फॉरगेट एनिथिंग. सो टेक इट लाईक सॉल्व द इक्वेशन म्हणजे ज्याच्यामध्ये ट्रान्सफॉर्म पण करणार आहे आणि इनव्हर्स पण करणार आहे. त्यामुळे मी फक्त दोन इक्वेशन्स देते तेवढ्याचं फक्त आन्सर काढायचं. फाइंड सॉल्व द इक्वेशन d square y by dt square plus y is equal to 2 e raised to t for y0 is equal to 0 and y dash is 0 is equal to minus 2. हे एक इक्वेशन आहे आणि हे एक दुसरं इक्वेशन. हे जमतंय का बघा, म्हणजे नसेल आलं नाही आलं तर आपण परत सॉल्व करू. डी स्क्वेअर वाय बाय डी टी स्क्वेअर प्लस 4y is equal to 9t with y0 is equal to 0 and y dash 0 is equal to 7. Just try करा. एक दोन दिवसानंतर मला नसेल येत तर कळवा. I'll share you the answers for this आणि मग परत ट्राय करा. And
Ma'am, please
Laplace
share the WhatsApp notes.
yes, I'll share everything, don't worry. And Thursday I'll be taking the Fourier transform. So that is a brief introduction along with where you can use the Fourier transform in the equations. So that application only we are taking. And together, Laplace and Fourier together, I'll be giving you the second assignment. Okay. But after submission of the first assignment, then I'll forward you the second assignment after completing this. That you can give it to me after 10 days. Means that date will be after 10 days. So don't worry. And next week onwards, Vaishali Joshi madam will be continuing for the numerical methods. Okay, and relax now because that part is completely numerical, no integration or nothing. So much easier than this one, transforms. Okay, only for the transform, lot of concentration as well as practice is required, so that the formulae you should know and how to apply and how to get the integration done. That is a different question. Okay, so can I close the meeting now? I think 34 members are there here. Just wait for a minute. I'll take your attendance. Yes, anything if you want to ask in between. Now I have formed that WhatsApp group, so you can ask me through that also. Okay, or if you have any difficulties, I'm there in the college. So those who are in the college, you can come and get your difficulties solved. Okay.
Yes, madam. Thank you.
Okay, see you then. Bye bye.
Ma'am, these transforms and what else is there in the syllabus?
Acha, okay, I have not shared that syllabus, no? Okay, I'll do it. Thursday I'll send you, otherwise in the WhatsApp group only. Transforms and numerical methods. This is only the syllabus. In the transform, these three transforms are there: Laplace, Fourier, and Z. Okay, and in numerical methods, various solutions you require it from the numerical methods only. So various solution means there are the interpolation formulae, there are the bisection methods. So where you are going to get the answer directly from the equations. Numerical calculation. So calculator is much more needed there, and you can do that calculations. Okay. Anyway,
so whether
I'll
there
send.
will be any, directly there will be one exam directly at the end. Now there is midterm kind of thing in between.
I don't know whether it is there or not, because last year they have taken, but this time still we have not received any notification. Maybe there. Ho sakti hai.
And the lectures we are having till what date? That is also means we haven't got academic calendar. That's why I am asking.
Lectures are there, I think, till 24th of March.
Okay. Thank you.
And in the first week of April, final exam will be there.
Okay.
Okay. Okay, then see you. I will close the meeting.
Ma'am, shall I leave the meeting?
Yes.